Moving right along in our discussion for this week, we're going to be talking about monatomic ions here and just chemical bonding in general for chapter 12. Our goals for this section, we want to be able to distinguish between cations and anions, and then also identify this thing called isoelectronic, or monatomic ions that are isoelectronic with a given noble gas atom, right? The electron configurations of those ions, okay? So that's what we want to do at the end of this video. And so a cation is a positively charged ion. So it has more protons than electrons. Formed when neutral atoms loses an electron. So for example, we saw this in the last video, maybe the video before that, in chapter 11. If I had a sodium atom that's neutral and I lost an electron, it's going to form a sodium cation, which is a sodium atom with a positive charge. And electrons are negative, so when you lose something negative, you get a little more positive, all right? And that's what's happening here with the sodium atom. It lost one electron, so it got plus one more positive, if you would, okay? An anion then is a negatively charged ion. It has more electrons than protons, and it's formed when a neutral atom gains an electron. So again, if I have chlorine here, I think we saw this example too, and I add an electron here, it's going to get more negative, okay? I'm putting the 1 there, but usually you'll just see a minus, okay? But I'm just trying to illustrate it's -1. It gained 1 negative electron. Okay, so what we're going to do here, let's actually just write the electron configurations for both of these guys. Just, going ahead a little bit. So let's just write the electron configurations for both of these guys then. So sodium, we saw this in the last video. I'm going to write it with a noble gas core. Okay, so it is neon 3s1. Okay, that's it, and it's neutral state, neon 3s1, excuse me. And again, if you're kind of wondering about that, go back to our other videos on electron configuration. So when it loses an electron, okay, it's losing this valence electron right here, okay? So it's going to be just neon, okay? Because it lost the 1 valence electron that it had. Chlorine here, okay, if I write its electron configuration, let me just see what we have here. So chlorine is neon, okay, 3s2, 3p5, okay? And so when it gains an electron, okay, it becomes neon 3s2, 3p6, okay? So this is illustrating what's going on when you're losing or gaining an electron. And you may be onto the fact, well, neon 3s2, 3p6, well, that's just argon's electron configuration, right? Because argon is 3p6. You're right, and that's what we're going to see in a second, okay? So the conclusion then is stable ions are formed by adding electrons to or removing electrons from a main group element so that it is isoelectronic with a noble gas atom. Isoelectronic just means same number of electrons. Okay, so same. That's what it means to be isoelectronic. And that's what we see here, okay? So these guys, if I kind of split the periodic table right here, where like around carbon is, okay? If I just split the periodic table, the guys on the left side of this split here are going to lose electrons, okay, to become like a noble gas. The guys over here are going to gain electrons, okay, to become like a noble gas configuration, all right? And we'll see examples of this as we go along. So, for example, lithium here, +1 means that it lost 1 electron. And when it does, I'm just going to erase this. If lithium lost an electron, it would be like helium, okay? Same idea here. If sodium lost an electron, it would be like neon. If magnesium lost 2 electrons, it would be like neon. If aluminum lost 3 electrons, it would be like neon, okay? If oxygen gained 2 electrons, it would be like neon. So this is what we mean by being isoelectronic, that these ions are either going to gain or lose electrons to be like a noble gas, okay? And we're going to see plenty of examples of this as we go along. Okay, and here's one of them right now. Write the electron configuration of the following ions, okay? So when you see that, when on a test, quiz, you see ions, that's, you know, okay, this is either a positive or a negative charge. With what noble gases are these ions isoelectronic? Okay, so let's write their electron configurations. So for calcium, for example, it is, let's see, it's in row 4, okay? So I'm just gonna go write a noble gas core for it. So this is gonna be argon. And so that took care of 18 electrons. Remember from our video electron configuration, I have 2 more electrons to deal with here because calcium has 20 electrons in its neutral state. Okay, so this is going to be 4s2 because it's in row 4 in the S block. So this is neutral, okay? This is just calcium. So if it wants to be isoelectronic with a noble gas, remember these ions either gain or lose electrons, okay, to be ions. And calcium is going to lose electrons. It's going to lose, in particular, these 2 valence electrons here. So when it does that, okay, it's going to have a noble gas core of just argon, and this is calcium plus 2. Okay? So how about I write this out like we were seeing it before with sodium, so it maybe makes a little bit more sense. So sodium or calcium plus 2 plus 2 electrons. So these electrons are gone, okay? They got kicked out. And so this is the answer right here. All right. So that's the electron configuration of the ion. It's just an argon noble gas core. And of course, you could write that out for yourself if you wanted. 1s2, 2s2, so on if you want. That's fine as well. Okay, so let's continue on here. So chlorine or chloride, as shown here, it's the name of the ion for chlorine. So let's just imagine it says chlorine for now so we don't get confused. I'll fix that a little later. So this is neon, okay? 3s2, 3p5. This is for just the neutral element. If I gain an electron, okay, so plus an electron, it's going to be neon 3s2, 3p6. Okay, and hopefully that makes sense. We gained an electron here, so we had room in the p orbitals. And now if you look here, remember it's going to gain electrons to be like a noble gas. So chlorine had 17 electrons, right, to begin with. And so when it gains one, it has 18 electrons, and that's the number of electrons that argon has. So actually, what we could do is just write this as the noble gas configuration for argon. Okay? So hopefully that makes sense. And if you're unsure, why don't you just pause the video and write out the electron configuration for argon, and you'll see that it matches chlorine, okay, or the chloride ion as it's shown here, which is the name of the anion. Okay, so that's it for ions, and then in the next video we're going to be talking about ionic bonds. So hopefully that last video made sense. If not, feel free to message me. As you do the homework, really pay attention to either gaining or losing electrons to be isoelectronic with noble gases. So see you when we talk about ionic bonding.